So in this video I want to cover something very interesting, well at least very interesting in my opinion. So in this video I'm going to cover neutrino particles. So neutrinos can be found in the cosmic ray spectrum and pass through any given matter that's... Oh yeah, aren't neutrinos those ghost particles you were talking about the other day? Watch out, they're everywhere. Why are you looking at me like that? It's not like you know anything about neutrino particles. Okay, ignore what he said. Obviously, there are no such things as ghosts. So neutrinos aren't ghost particles. They do, however, pass through matter, but they're not ghost particles. So the first question you might ask yourself when learning about neutrinos is, where do neutrinos come from? So as I stated earlier in this video, neutrinos can be found in the cosmic ray spectrum. So cosmic rays are particles from outer space that bombard the Earth. And these particles can come from the sun, planetary collisions, black holes or the quasars emitted from black holes. Those are more tied to gamma rays. Cosmic rays can also result from supernovas. So for those out there wondering what a supernova actually is, a supernova is the result of the death of a supermassive star. So in explaining neutrinos, as I've done in other videos, but this time briefly, we have fermions and bosons. But in the fermion group, we're going to have to be, in this video, paying attention to really the lepton group. So within the lepton group, within the standard model of particle physics, you have electrons, muons, and tau particles. And alongside the electrons, muons, and tau particles, you have the electron neutrino, the muon neutrino, and the tau neutrino. So some of you out there might have been wondering why neutrinos pass through matter so easily. Why can't we detect them? It is true. When neutrinos come as cosmic rays, they usually pass straight through you and straight through the Earth itself. So this is where the standard model of particle physics would come in handy again. So quarks, in the quark family, within the quark family, up and down quarks compose protons and neutrons. The protons and neutrons will have different combinations of up and down quarks. Protons have two up quarks and a down quark, and neutrons on the other hand are composed of two down quarks tied to an up quark. So when looking at an atom, along with the proton and neutron that the up and down quarks account for, you would find electrons. So within the standard model of particle physics, the up and down quarks interact with a strong nuclear force and the electrons interact through the electromagnetic force. However, the electron neutrino, the muon neutrino, and the tau neutrino each interact with a weak nuclear force. So these particles, these neutrino particles, don't share any force in common with the original constituents of matter, which is why they don't interact with them. So the reason why neutrinos pass straight through the Earth is that they simply don't interact with any matter that composes the Earth, thus being invisible to the Earth or to any detectors that could pick them up. So another interesting thing about neutrinos is that most of the thousands of neutrinos that are passing through you each and every second, the neutrinos that are passing through you even right now as you're watching this video, originated from times around the Big Bang, so about 15 billion years ago. So neutrinos are neutrinos. As I've stated earlier in this video, there are electron neutrinos, muon neutrinos, and tau neutrinos. But don't get confused. Although electrons are of negative charge, neutrinos again don't interact with the electromagnetic force, thus not having any charge. So neutrinos don't have negative charge. And also, they, aside from not sharing any forces in common with the constituents of matter, they are massless. So that's why that's also why you would see neutrinos passing straight through matter. These neutrino particles just act like ghosts. So you understand the concept of neutrinos now?
If you enjoyed this video, please like, subscribe, and share.